Okay, here we go with a question about sound waves. Okay, lots of nice common bits here, lots of recurring themes. Okay, so as ever, please try the question before you watch this video. However, if you're ready to watch on, please do so. So we've got, again, like I say, some really standard ones. So first one here is just talking about sound and how it travels in solids, liquids, and gases. Okay, you're going to identify the state of matter in which sound travels. Well, fastest and slowest, or slowest and fastest, I should say. This is fully linked to spacing, okay? The closer the particles, the faster the waves spread. So remember, sound travels via vibrations, more on that in a second. Okay, and if you've got a gas, which is the slowest, it's due to the fact that those particles are spread out. In the solid, those particles are close together, and so therefore the vibrations pass quickly. All you've got to do here is gas and solid, never liquid here, okay? Now, more on that now. We're going to talk about how sound waves travel through air, okay? And the first thing I would say in any statement about how sound waves travel, I would talk about sound waves traveling via vibrations. Vibrations is a bit of a weird one when we're talking about air, but we'll go with that for now. We have sound waves traveling via vibrations, okay? And these as a result, those collisions between the particles create areas of high density and low density. And those are called compressions and rarefactions. CIE really likes it when you use the words compression and rarefaction because it shows that you understand that we have these areas of high and low pressure, high and low density, okay? And those transfer the energy, the sound energy, from the source to the receiver. So you've got the flow of those compressions and rarefactions which move in the direction of the energy transfer. We're then, sticking with sound, going to state the frequency range of human hearing. We've got 20 hertz at the bottom end, 20,000 kilohertz, or 20,000 hertz or 20 kilohertz at the top. Just to be clear, this is not 100% true. If you ever do a hearing test, you might be able to hear less than this. But this is the range that we use in here. So 20 to 20, just remembering there's a hertz here and a kilohertz here. We're now going to move on to electromagnetic radiation. We'll look at ultraviolet. Ultraviolet has nothing to do with sound, but it is another wave. We use that for a few things. You can have sterilizing medical equipment or detecting counterfeit money. Okay, so it's a good way of checking whether your money is real or not. Yeah. Now we're then going to talk about dangers. A danger could be burning your skin or getting skin cancer. Again, these are very standard answers. Just make sure you're aware of them. Again, speaking of standard things, it's back again. It's the wave equation. I've recorded so many videos now, and by far and away the most popular equation is this one. We know the infrared has frequency 2.2 times 10 to the 12. The speed of light is 3 times 10 to the 8, and we want to know the wavelength of it. So we're going to use V equal F lambda. Lambda is V over F. We're going to take our ratio, and we're going to get what is apparently quite a small number, but actually in the scheme of things, not too small. Okay, this is our infrared wavelength. Again, I think on the mark scheme it says 1.4 times 10 to the minus 4. The answers, as long as you've made sure you've used the wave equation, you should be fine here. I think one thing to reflect on here is that they could have not given you this number. I was surprised that this number was in the question because you should know that all electromagnetic waves travel with the same speed. So, and that speed is 3 times 10 to the 8. So this is a bit of an easy one. I can imagine this being a 3-mark question where they don't give you the speed and they're relying on you to acknowledge that it's an electromagnetic wave, it has the same speed as light, and so therefore it can be applied. However, that's not the case here. I'm overcomplicating as usual. Okay, I hope that's of some help.